Good morning. It's February 10th, and this is your daily brief in science. Here's everything you need to know. The European Space Agency's €1 billion Euclid mission, in partnership with NASA, is set to delve into the enigmatic realms of dark matter and dark energy, which together make up 95% of our universe. Recently, the mission achieved a significant milestone by discovering an Einstein ring, a phenomenon where light from a distant galaxy bends around a massive foreground object. In this case, the foreground object is the elliptical galaxy NGC 6505, which is encircled by a striking circle of light, revealing a more distant galaxy behind it. This image captures bright blobs that represent replicated images of that distant galaxy. Astronomers estimate that NGC 6505 contains approximately 11% dark matter, a relatively low figure compared to the universe's overall dark matter content. Notably, only 5 other gravitational lenses have been identified as close to Earth as NGC 6505, with simulations indicating a mere 0.05% chance of this lens existing. Conor O'Riordan from the Max Planck Institute emphasized the scientific significance of this rare gravitational lensing phenomenon, highlighting both its beauty and its proximity to Earth. Professor Thomas Collett from the University of Portsmouth pointed out the importance of this lens for testing Albert Einstein's general theory of relativity. While strong gravitational lenses are not the primary focus of the Euclid mission's research, they serve as valuable testing grounds for scientific hypotheses and Einstein's theories. The mission is expected to discover around 100,000 strong gravitational lenses, a dramatic increase from the fewer than 1,000 known previously. These Einstein rings are crucial for studying the universe's expansion, as well as dark matter and dark energy. The Euclid Consortium, consisting of over 2,000 scientists from various countries, is responsible for the mission's scientific instruments and data analysis. The findings regarding this discovery were published on February 10, 2025, in the journal Astronomy and Astrophysics, reinforcing the promising future of the Euclid mission. A recent study published in Nature Medicine has uncovered troubling findings regarding microplastics in human brain tissue. Researchers discovered that individuals can have up to a spoon's worth of tiny plastic shards embedded in their brains, raising concerns about potential health implications. While the effects of these microplastics on human health remain unclear, prior research has suggested a possible connection between higher concentrations of microplastics in arteries and increased cardiovascular risks. Notably, brain samples from 12 dementia patients contained up to 10 times more microplastics compared to samples from individuals without dementia, though a direct causal link has not yet been established. The study indicates that microplastics may accumulate in fat cells within the brain's myelin sheath, which could explain their heightened presence in brain tissue. Environmental scientist Antonis Miradakis has emphasized that, despite the alarming findings, it is premature to draw definitive conclusions about the direct health risks posed by microplastics in the brain. Researchers suggest that microplastics primarily enter the human bloodstream through contaminated food sources, particularly meat, highlighting the widespread prevalence of plastics in agriculture. This cycle of plastic contamination in the food chain is worsened by practices such as using plastic-laden water for irrigation and feeding livestock with contaminated feed. Experts, including Campen, have expressed concerns that microplastics might disrupt neural connections and contribute to protein aggregation associated with dementia. Previous studies have also found microplastics in various human tissues, including lungs, placentas, and testes, indicating that contamination is widespread across the human body. This research is crucial as it addresses an emerging area of concern regarding the accumulation of plastics in human bodies, a topic that has not received much attention. The long-term persistence of plastic in the environment is alarming, especially given that single-use plastics, designed for brief use, can last for centuries. Experts are currently investigating methods to reduce microplastic exposure, including the use of enzymes for breakdown and techniques to collect them from the ocean. Recently captured video footage has revealed the presence of 2 rare black wolves in a Polish forest, likely siblings. This discovery was reported by the Save Wildlife Conservation Fund and recorded last year by project coordinator Joanna Totzydlowska, who initially aimed to study beavers. In the footage, a striking moment shows a black wolf alongside a gray wolf crossing a stream, while another clip features two black wolves with a gray companion. The two black wolves weigh around 30 kilograms, or 66 pounds, and are estimated to be about a year old, with at least one confirmed as male. In Poland, the majority of the wolf population is gray, with black fur being uncommon due to a genetic mutation associated with domesticated dogs. Wolves in Poland were nearly extinct by the 1950s, but have seen a resurgence in population, particularly in central Poland since the early 2000s. To better understand the genetics of these rare black wolves, the conservation organization is collecting scat samples from the forest and has requested financial support for genetic testing. To safeguard the wolves from poaching, the exact location of the sighting remains confidential, while the organization emphasizes the importance of education about coexisting with wolf populations. Interestingly, while black fur is rare in Poland, approximately half of the wolf population in Yellowstone National Park exhibits this coloration. This video footage has sparked further research into the genetics of the black wolves, underlining their unique characteristics and ecological significance. The Conservation Fund's announcement on Facebook has raised awareness about these wolves and marks a significant conservation success story, reflecting ongoing efforts to restore wildlife populations. Researchers at Tel Aviv University have made a notable advancement in drug delivery systems. They have successfully developed a method to deliver lipid nanoparticles containing messenger RNA, or mRNA, directly to the immune system in the intestines, bypassing the liver entirely. This breakthrough involved encapsulating the anti-inflammatory protein interleukin-10 in lipid nanoparticles, which were then delivered to animal models suffering from Crohn's disease. This approach effectively transformed immune cells in the intestines into factories that produce the beneficial protein. To optimize absorption by intestinal cells, the research team utilized a specific ratio of phosphatidylcholine in the lipid nanoparticles. By increasing the phospholipid content from 10% to 30%, they improved targeting to the intestines, as this formulation more closely mimics biological membranes. This innovative method holds promise for treating chronic inflammatory diseases, such as Crohn's disease and ulcerative colitis, which affect about 7 million people globally, including 15% of the U.S. population. Professor Dan Peer highlighted that traditional drugs often accumulate in the liver when injected into the bloodstream, which can lead to toxicity. The study indicates that by adjusting the lipid composition of these nanoparticles, it may be possible to target other organs as well, paving the way for new therapies for conditions like colon cancer. The research team, led by Dr. Ricardo Rampado and Professor Peer, plans to explore further adjustments to enhance targeting capabilities for various organs. This study, published in Advanced Science, may expedite clinical studies for drug production. The discovery, made during random screenings, suggests broad therapeutic applications and potential benefits for healthy individuals, too. Overall, this research opens new avenues for delivering RNA-based drugs to specific organs by fine-tuning nanoparticle formulations. A recent study conducted by researchers from University College London and the University of Glasgow has revealed alarming insights into the impact of COVID-19 on individuals with rare diseases. This research, supported by the BHF Data Science Centre at HDR UK, is the first extensive analysis examining the prevalence of rare diseases and their associated risks during the pandemic. The study analyzed linked electronic health records from over 58 million people, focusing on 331 rare diseases. Findings indicated that individuals with rare diseases were nearly 5 times more likely to die from COVID-19 compared to the general population. Specifically, infertility disorders and kidney diseases were identified as presenting the highest risks. Among vaccinated individuals, 8 rare diseases were found to significantly increase COVID-19-related mortality. The 3 diseases with the highest risks included bullous, pemphigoid, osteogenesis imperfecta, and autosomal dominant polycystic kidney disease. The research also highlighted that public health measures, such as the UK's shielding list, often excluded patients with rare diseases, leaving many vulnerable individuals unprotected. The study, published in The Lancet Digital Health, underscores the necessity for improved inclusion of rare diseases in public health strategies, particularly in pandemic planning and vaccination policies. Lead author Dr. Johan Tegeson pointed out that the lack of fundamental data about rare diseases has hindered effective healthcare planning during the pandemic. Co-author Professor Honghan Wu emphasized the potential of early detection and data linking to enhance treatment and support for patients with rare diseases, advocating for better integration of these conditions into public health decisions. Historically, rare diseases have faced neglect in research due to difficulties in gathering large-scale data, resulting in inadequate treatment and support for affected individuals. The comprehensive approach of this study benefits from the UK's extensive health data coverage and diversity, further enhancing its findings and implications for healthcare. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.